Welcome to Unit 2, Lesson 18, Representing Situations with Inequalities. This lesson begins the second half of Unit 2. And most of what we're going to do in this second half, you did during the first half. The difference is, in the first half, you were working with equalities, where we said one side of the equation was equal to the other side. Now we're going to be using inequalities, so we're saying one side of the equation is less than, greater than, less than or equal to, or greater than or equal to the other side. So this makes a difference in how we're going to solve it, what our solutions look like, and how we end up graphing it. But the main components of what we're doing are still going to be the same as when we were following it for equations. So you can always fall back on the knowledge from the first half of the unit. Our learning goal today is to use inequalities to represent constraints in situations. And in this first lesson, we only have one learning target. I can write inequalities that represent the constraints in a situation. So if you remember back to the first half of Unit 1, we started out learning how to take word problems that represented a situation, and we turned those into equations. Well, in Lesson 18, we're going to do the same thing, but this time we're going to be using inequalities to represent the situation rather than an equation. Now we can begin the practice problems for Algebra 1, Unit 2, Lesson 18, Representing Situations with Inequalities. In our first problem, Tyler goes to the store. His budget is $125. Which inequality represents X, the amount in dollars Tyler can spend at the store? So let's point out the important parts. We know that the budget is $125, and we know that X is the amount in dollars Tyler can spend at the store. So a few things here. First, budget is the maximum amount you can spend. This means you can spend less, you can spend exactly, you cannot spend more. So anytime you see this word budget, you are going to use a less than or equal to symbol. We know that they want us to use X to represent the amount in dollars Tyler can spend at the store, and we know that that budget is $125. So if we look at our choices, A is the correct choice. If we look at the others, This says he can spend more, or exactly. So that one's wrong. When we look at C, C says he can spend more, or he can only spend more. Which is wrong. And D says he can only spend less. So D is wrong. A is correct because the budget means he can spend less than $125 or he can spend exactly $125. If you have any questions about how to solve this practice problem, please use class time to ask for further clarification before we move on. Our next practice problem, Jada is making lemonade for a get-together with her friends. She expects a total of 5 to 8 people to be there, including herself. She plans to prepare 2 cups of lemonade for each person. The lemonade recipe calls for 4 scoops of lemonade powder for each quart of water, and each quart of water is equivalent to 4 cups. Let N represent the number of people at the get-together, C the number of cups of water, L the number of scoops of lemonade powder. They want us to select all the mathematical statements that represent the quantities and constraints in the situation. So what we're going to do is look and see what each one says and then see if that is correct. N represents the number of people at the get-together. So A says more than 5 people, but less than 8. But that wouldn't be correct because then that's not including 5 people or 8 people, and she is expecting a total of 5 people to 8 people. So A would not be correct. B, on the other hand, because it has the less than or equal to symbol, says at least 5 people but no more than 8. This one is correct because it includes 5 and 8. So that is the difference between a less than symbol and a less than or equal to symbol. If it has the or equal to, then it is including those numbers on the end. If it only has a less than, it is not including those numbers on the end. Now we look at C. C represents the number of cups of water, so that's number of cups of water equals 2 times number of people. Well, if we look back at the story, up in blue we highlighted she plans to prepare 2 cups of lemonade for each person. So if you take each person, you multiply them by 2, that will give you the total number of cups of water that you need. So that is true. C is a correct equation to represent this situation. Now we look at D. D says L equals C. Well, if we look in green, L is the number of scoops of lemonade powder. So, scoops of lemonade powder equals C, which in green, C is the number of cups of water. And if you look up in yellow, 4 scoops of lemonade for each quart, and each quart is 4 cups. That means 4 scoops of lemonade powder equals 4 cups of water, so the scoops of lemonade powder does equal the cups of water, so D is another equation that correctly represents this situation. And finally, we look at E. This says the cups of water are going to be more than 10, but less than 16. But this is the same problem we had in A. It's not including the possibility of 10 or 16, which would happen if there are 5 people or 8 people. So E is not a correct equation. And finally, F says L, which is the number of scoops of lemonade powder, is going to be at least 10, but no more than 16. And we said the scoops of lemonade equals the cups, and it's going to be 2 cups per person. So if we take equation B and we multiply that by 2, then we are going to have at least 10 scoops of lemonade powder, but no more than 16. Because of the less than or equal to symbol, this does include the 10 and the 16, which is needed in this situation. If you have any questions about how to solve this practice problem, please use class time to ask for further clarification before we move on. Our next practice problem. A doctor sees between 7 and 12 patients each day. On Mondays and Tuesdays, the appointment times are 15 minutes. On Wednesdays and Thursdays, they are 30 minutes. On Fridays, they are 1 hour long. The doctor works no more than 8 hours a day. Here are some inequalities that represent this situation. So, let's highlight the important parts. We know that there are between 7 and 12 patients each day. On Mondays and Tuesdays, the appointment times are 15 minutes. On Wednesdays and Thursdays, they are 30 minutes. On Fridays, they are 1 hour long. The doctor works for no more than 8 hours a day. Number 1, what does each variable represent? So the first one is y, and we know that y is at least 0.25, which is the same as 1/4. And we know that it's no more than 1. So if we look up at our highlighted areas, this matches the highlighting in green. "15 minutes is 1/4 of an hour, or 0.25. And 1 hour would be represented by the 1. So the shortest appointment time is 15 minutes on Mondays and Tuesdays. The longest appointment time is 1 hour on Fridays, and the 30 minutes on Wednesdays and Thursdays is in between. So for number 1, y equals time of the appointments. Now we look at the next one. X is at least 7, but no more than 12. This matches the highlighting in blue. And that said there was between 7 and 12 patients each day. So X equals the number of patients each day. And now number 2, what does the expression xy in the last inequality mean in this situation? So we see that it says xy, which is x times y, is less than or equal to 8. Well, this matches our yellow highlighting. The doctor works no more than 8 hours a day. So xy equals number of patients multiplied by time of the appointments. Together, that must be no more than 8 hours a day. If you have any questions about how to solve this practice problem, please use class time to ask for clarification before we move forward. Our last practice problem, Han wants to build a doghouse. He makes a list of the materials needed. At least 60 square feet of plywood for the surfaces, at least 30 feet of wood planks for the frame of the doghouse, and between 1 and 2 quarts of paint. Han's budget is $65. Plywood costs 70 cents per square foot. Planks of wood cost 10 cents per foot, and paint costs $8 per quart. Write inequalities to represent the material constraints and cost constraints in this situation. Be sure to specify what your variables represent. So first, I'm going to list what my variables represent. We know that we're going to need at least 60 square feet of plywood, so I'm going to use P for square feet of plywood. Next, we know we need at least 36 feet of wood planks. So I'm going to use W to represent feet of wood planks. And then we know that we need between 1 and 2 quarts of paint. So I'm going to use Q to represent quarts of paint. And the last variable we'll need is Han's budget being $65. I'm going to use B to represent budget. Now, if I wanted to write these inequalities, I know that we need at least 60 square feet of plywood. So that means P, my square feet of plywood, needs to be greater than or equal to 60. It could be more than 60, it could be exactly 60, but it cannot be less than 60. The next inequality I would use is to represent the feet of wood planks. And we know up here in blue, we need at least 36 feet. So that means W needs to be greater than or equal to 36. It could be more than 36 feet of wood, it could be exactly 36 feet of wood, but it cannot be less than. The next one we have highlighted in green here says we need between 1 and 2 quarts of paint. So we know that our Q needs to be between and including 1 and 2. So it could be equal to 1 or greater than 1, and it could be less than 2 or equal to 2. Now the last thing we need to worry about is the cost. We know that plywood is going to be 70 cents per square foot. When we write that, we could write 0.70p. Next, we know that wood planks are 10 cents per foot. So when we write that cost, it would be 0.10W. And the last cost that we know is paint costs $8 per quart. So when we write that cost, it would be 8Q. And we know that because it is a budget, it could be less than or equal to 65. So altogether, the cost for the plywood the cost for the wood planks and the cost for the paint could be less than $65, or it could be exactly $65, but it could not be more than $65. So now we've represented all of our variables. We've represented the three inequalities that track the quantities of the plywood, the wood planks, and the quarts of paint. And we've created the inequality that represents the cost. The budget, since we knew that it was $65, we don't need a variable for that. If you have any questions about solving any of the practice problems in this lesson, please use class time to ask for further clarification before we move forward into lesson 19.